Hi, pre-algebra students. These are your notes for section 5.2 on solving systems of linear equations by substitution. So in this section, we're going to learn how to solve for x and y. And because we have two equations and two variables, you cannot just use inverse operations like we normally do to solve a linear equation. So solving by substitution is one way to do this algebraically so that we don't actually have to put both of the equations on a graph to find their solution. So please take a minute to read through the steps and the key idea. This is always an important process to keep in mind and remember as we're working through, and then I'll just kind of talk you through those as you go. Okay, so we're going to start by looking at example number 1. Okay, so in example 1, we have two equations. Y equals 2x minus 4. I'm going to call that our first equation. And 7x minus 2y equals 5. I'm going to call that equation 2. So the idea is to look for one equation where you already have a variable isolated. So do you see right here y is already isolated in my first equation? So I'm going to take the value of y in the first equation and I'm going to substitute it in place of y in the second equation. So using this equation, I'm going to substitute it there. So step 1 is just a substitute. So it will say 7x minus 2 times 2x minus 4 is equal to 5. Okay, so this part right here, the 2x minus 4, is what I substituted in place of y for the first equation. Once you substitute, now you can go ahead and solve for x. So using my equations work, I'm going to distribute. When you distribute, please remember there is a subtraction sign in front of 2, so you're distributing a negative 2, everything inside parentheses. So we have 7x, negative 2 times 2x is negative 4x. And then here, a negative times a negative is a positive. 2 times 4 is 8. So really be careful and pay attention to your signs. Okay, so once you distribute, you're just going to continue with your equations work. So here I would combine my like terms. 7x minus 4x is 3x. Bring everything else down. Now we're left with a simple two-step equation. So in the first step, I'm going to go ahead and subtract 8 from both sides because I want to isolate that term containing my variable. So now I have 3x equals negative 3. Again, watch your signs. So I divide by 3 on both sides. So x equals negative 1. Okay, so I've solved for the first variable. Here's the part that you have to remember. You're not finished because we need to know what is the value of x and what is the value of y. So once you find the value of the first variable, you're going to substitute that in place. Whoops, I meant to change that. Let's substitute it in place of x in either of the two equations in order to solve for y. Obviously, the easier of the two equations would be that first one that already has y isolated. So I'm going to use the equation y equals 2x minus 4, and I'm going to use that value of x that I just found to help me find the value of y. So when x equals negative 1, I'm going to substitute it right there and just solve this using order of operations. So 2 times negative 1 is negative 2 minus 4. So y equals negative 6. Okay, quick reminder of a couple of things before we move on. First of all, please remember that when you solve a system of linear equations, your solution should always be written as an ordered pair in the form of x comma y. So my solution here is negative 1 comma negative 6. Also, remember the way that I check my equations is by substituting my solution back in place of x and y. So since I've already used the first equation, I can check my answer by substituting negative 1, negative 6 in place of x and y in the second equation. So when x is negative 1 and y is negative 6, it looks like this. So I'm going to check it and make sure that both sides are the same. 7 plus 12 is positive 5. So that proves that the answer that I found is correct. Okay, now it's your turn to try 3 of these on your own. Do the best you can. I know that you've only seen one example, but take your time, read through the key idea again, and do your best, and we'll go over those tomorrow. Pause your video if you need to, and then we're going to go ahead and look at example 2. Okay, so in example 2, notice we have a real-life application problem. So this is a word problem. It is going to be more challenging, and we'll spend lots of time revisiting these and practicing them together in class. So the first thing I always do is read through the word problem and look for my key information. So here it says you buy a total of 50 burgers and veggie burgers. So that's the total number of items. And then I'm spending $90. So notice I'm going to keep this, even though it's in the first sentence, all of my cost information is going to go together. So it's $90 for 2 turkey burgers and $1.50 for each veggie burger. So then in the last sentence, it says write and solve a system of linear equations, which means I need 2 equations, and I'm going to find the number of x of turkey burgers. So that means x is going to be the number of turkey burgers, and y is going to equal the number of veggie burgers. So y equals number of veggie burgers. Okay, this is called writing a variable statement when you tell exactly what your variables are going to represent. So now that I know what my variables represent, I'm going to use these 2 pieces of information to help me write 2 equations. So if I have a total of 50 turkey burgers and veggie burgers, total tells me that I need to add together. So that first equation is the x plus y equals 50. That says I have some turkey and some veggie for a total of 50. Okay, my next equation is going to involve the cost. So it's $2 per turkey burger. So that tells me to multiply. So 2x means 2 times x, so 2 for each turkey, and $1.50, I can just write that as 1.5 or 1.50 for each veggie burger for a total of $90. Okay, now if I'm going to solve this using substitution, I have to get one variable isolated. So because the first equation looks simpler, I'm going to choose this one, and I'm going to solve for either x or y. It really doesn't matter. So in this equation, I'm going to subtract y from both sides. Remember, you can't combine terms over here. So it now says x equals negative y plus 50. Okay, now that I have my variable isolated, I can take this value of x and I can substitute it in the second equation and solve. So I'm going to put that value in place of y. Sorry, not in place of y. Let me get rid of that. I'm putting it in place of x because it says x equals that. So it's going to go here in place of x. So 2 times negative y plus 50 plus 1.5 y is equal to 90. Okay, keep in mind it would be okay to write 50 minus y. It means the same thing. So when you substitute that in, you're going to distribute here. So that's negative 2y plus 100 plus 1.5 y equals 90. I'm going to combine my like terms, which are my y's. Negative 2 plus 1.5 is negative 0.5 y plus 100 equals 90. Continue solving your equation. So subtract 100 from both sides. So this is a 2-step equation. Okay, now have negative 0.5 y is equal to negative 10. So my last step is to divide both sides by negative 0.5, which seems confusing, but you do have a calculator. So just keep in mind a negative divided by a negative is a positive. And in your calculator, you can do 10 divided by 0.5, which is 20. So it works out nicely, okay? So remember, once you find the value of y, you're going to plug it back in one of the equations and find x. So again, using that first equation, which was easier, if x plus y has to equal 50, we just figured out that y is 20, so plug that in there. So x plus 20 equals 50. So if you subtract 20 from both sides, you can see that x is equal to 30. Okay, when you solve a real life problem like this is the only time we don't really write our answer as an ordered pair. So you would write your answer using a sentence. So if x is 30 and y is 20, that means I have 30 turkey burgers and 50 veggie, oh, sorry, not 50, 20 veggie burgers. You fix that. Okay, so I'm going to fix that, and then you need to try the next one on your own. So 20 veggie burgers. Okay, try the next one on your own. Like I said, don't get too frustrated. We're going to work on this a lot together. Okay, good luck and have a great night.